Hello everyone, welcome to Computer Organization and Architecture class. In this unit, we will talk about networking and communication. Communication is the process of transmitting information from a source to a destination. For example, using telephone is a common way to communicate. When making a phone call to your friend, one person is talking while the other person is listening. Basically, voice is an audible sound, and telephone line is transmitting electrical signals. Therefore, a device is required to convert audible sounds to electrical signals at sender side and convert electrical signals to audible sounds at receiver side. This device is known as modems, which is a contraction of modulator, demodulator. As you can see, there are telephone lines connect telephones to telecommunication facility, which create a huge network known as Public Switched Telephone Network, PSTN. Similarly, all mobile phones also forms wireless networks using different wireless communication technology such as 4G and 5G networks. It is worth mentioning that 5G is not only 100 times faster than 4G networks, but also has low latency. Latency means the time required for a set of data to travel between 2 points. Low latency is one of the necessary conditions for the fulfillment of massive IoT, Internet of Things, which is expected to help heavy industry and big data enterprises to expand, innovate, and globally scale their operations. The aforementioned networks provide communication among a wide service area and thus known as Wide Area Network, WAN. As aforementioned, a modem converts between transmitted binary sequence into high or low values as shown on the screen. The binary pattern 10110001 is represented by an ideal wave, which is approximated by a transmitted wave with slightly distortions. The degree of distortion varies with transmission medium. 5 commonly used transmission mediums are illustrated on the screen, including 2-wire open lines. Second, twisted pair lines. Third, coaxial cable. Fourth, optical fiber. Fifth, satellite. The 2-wire open lines is one of the simplest setting. Typically pick up noise with a short transmission distance for about 50 meters. Twisted pair lines such as Category 5 network table, which is more reliable in signal transmission over 100 meters. Coaxial cables such as your TV cable, which can be used for higher speeds with longer distances. Optical fiber such as the Verizon Fios that use optical fiber to transmit light signal, which is immune to electromagnetic interference and crosstalk, and supports a much wider bandwidth. Satellite such as DirecTV, which transmit microwave signals via satellite that has broad area of coverage. The transmitted signals may be influenced by noise, which introduce errors in the transmission. Therefore, error detection and correction techniques are used in the network transmission. For example, parity or ECC techniques used in the memory and mass storage devices are commonly used in network transmission. All networking and network device architecture follow the Open System Interconnection (OSI) model, as shown on the screen. The OSI model is a set of protocols established by the International Standards Organization (ISO) in an attempt to define and standardize data communication. In the OSI model, the communication process is divided into 7 layers from bottom to top, including physical, data link, network, transport, session, presentation, and application layers. Contrarily to Wide Area Network (WAN), a local area network (LAN) is a communication medium that interconnects devices over a limited geographical distance of a few kilometers at most. A LAN allows a set of closely grouped computers and other devices to share common resources such as data, software applications, printers, and mass storage. There are 3 primary LAN topologies as illustrated on the screen. The 3 organizations include bus topology, ring topology, and star topology. Bus topology is the simplest of the 3. The advantages of the bus topology includes directly communication between devices and simple to add a new device to the network. However, the break of the bus cable will disrupt the network. Ring topology attempts to ease the problem of bus topology by joining the 2 ends of the cable. The data packets are passed around the ring until they reach their destinations. Star topology connects each device to a central hub that serves as an intermediary for all communication over the network. The advantages is that any cable break only interrupts one device. The disadvantages are the problem of hub affects the entire network and it requires more cable than a bus or a ring. However, star topology is very commonly used in the LAN. Ethernet is a commonly and widely used LAN and WAN, which uses carrier-sense multiple access with collision detection for transmission. When a network device wants to transmit data, it first listens for a carrier. If there is a carrier present on the line, which is placed there by a transmitting device, then it transmits nothing and listens again after a random waiting period to prevent deadlock. If there is no traffic on the line, then transmission can begin by placing a carrier on the line with the data. The source also listens for collisions in which 2 or more devices simultaneously transmit. When collision occurs, the transmitting devices Wait for a random interval before retransmitting. One of the most commonly used network protocol is TCP/IP protocol, as shown on the screen. At the bottom of the protocol stack is the link layer, which is made up of physical and medium access control (MAC). Network layer is implemented with the Internet Protocol IP for the Internet. Transport layer is implemented with the Transmission Control Protocol (TCP). At the application layer, a process can exchange data sockets with another process anywhere on the Internet and treat the connection as if it were a file on the local system. It reads and writes bytes with ordinary read and write system calls. Every interface on the Internet has a unique IP address. Version 4 of the IP protocol, known as IPv4, is widely used, but is gradually being replaced by IPv6, which uses addresses that are 4 times wider and has several enhancements and simplification of IPv4. A router is a device connects one network to another. For example, in your home, a router is installed to allow you to connect your devices in LAN at home to the Internet WAN. Any questions?